Diffusion. When we talk about diffusion, like I told you the last time, that it is the movement of molecules or ions from a region of higher concentration to a region of lower concentration until it is evenly distributed, or until it reach an equilibrium and a balanced state. Now, what do I mean? Remember the other time I told you about perfume, quite alright. Do you remember?
Yes, ma'am.
What did I say about the perfume the other day?
Yes, that's when you spray it in a room.
Okay.
Someone that's in the parlor smell it. That it is when it goes in the parlor, that's dilution. When it goes from a larger concentration to a smaller concentration.
From an higher concentration to a lower concentration, from an higher concentration to a lower concentration. Thank you very much for that example. Now, do you know that it will now get to a stage whereby it is the same way you perceive it in the sitting room that you'll be perceiving it in the room? You don't understand. This,
No.
it will get to a stage that the strongness in that perfume, the smell, it will what? It will balance up. Is that taken? That it will no longer be that strong in the room because it has diffused. It has moved to different places. Do you understand?
Yes, ma'am.
So that is why we said until it is evenly distributed or until it's reached equilibrium state. Is that taken? And when we talk about, what do you mean by, what do you understand by equilibrium?
When it is balanced.
When something is balanced. So until it's balanced up, that is either we do not hear it again or we all smell it equally. It is no longer higher in a place and lower in a place. It now smells in all places equally. So that is what we mean by diffusion. It is the movement of what? Molecules or ions from a region of what? Higher concentration to a region of what? Lower concentration until equilibrium is reached or until it is evenly distributed. Do you understand?
Yes, ma'am.
Okay. Now let's look at more definition. When we talk about diffusion, we don't need any energy. Is that taken now? No energy is needed. No any ATP is needed. Then when we are talking about concentration gradients, how does it move? How does it move? It moves from a high concentration to a what? To a low
Yes.
concentration. And here we are talking about equilibrium. It means that what? The concentration must now be equal at both sides, whether in the room, whether in the sitting room, the concentration must now be equal. The smell will now be what? Equal. So that is definition of division. Movement of what? Molecules or ions from a region of what? Higher concentration to a region of what? Lower concentration until it is until equilibrium is reached. Is that taken? So that is the definition of what? Of diffusion. Now, diffusion occurs both in gas, it occurs in liquid, and it occurs in what? In solid. Now, of the three states in which diffusion occur, which one do you think will be the fastest?
Gas.
Gas. Because gas, it's why is it very fast? Why?
Because of the particles in it are not packed together.
Yes, they are very, very free. They are not packed. They are free. They move freely. Is that taken now? So their gas is the fastest because the molecules move freely and rapidly. Do you understand? Then
Yes.
when we talk about gas, it occurs in all direction. It's not that you are putting a bowl down, you are not checking the bowl or anything. No, it deals with air. It just keep going. Any direction you find it. Any direction you find it. So it occurs in all direction. An example is the perfume spreading across a room. Is that taken? So let's look at diffusion in liquid. It is not as fast as that of gas, but it is still a little bit faster compared to what solid. Liquid is at the middle. So when we talk about liquid, molecules move but are closer together. Unlike gases, that the molecules are very, very free. They are not closely packed. They are not close together. Everybody moves their own. So when we talk about diffusion is liquid, it is slower compared to what? To gas. And the other day I gave you an example of a dye. That when you spread dye in water, it will move not too slow, but it will move slowly, slowly, slowly until it's what? It's diffused to the whole water. So when we talk about solid, their molecules are very, very tightly packed, and that is why their diffusion rate is usually very slow. It is usually very slow, and most times it requires a very high temperature for diffusion to what? To occur. In fact, in biology we don't really take it serious. The diffusion in solid, we don't take it serious because it takes a very long time. Do you understand? So when comes
Yes.
to solid, diffusion is very low. Why? Because their molecules are tightly packed. Do you understand? And because it requires what? A very high temperature for diffusion to what? To occur.
Ma,
Do you get it? Yes.
you said it requires a very high temperature. You said that it requires high temperature to occur.
Yes, yes, yes.
So if it require high temperature, when the high temperature it occurs on the solid, like I give example here, gold and lead, it
Okay.
melts, and when it melts,
Yes.
it turns to liquid state. So is this
Okay.
still diffusion for liquid? Is this diffusion for solid or rather liquid?
It is solid because it was in its solid state before we went to melt it. It was in its solid state before went to what? To
Yeah.
melt it. Do you understand? Gold was in a solid state and lead was in a solid state. So when they are now pressed together, the two of them, do you know they will solidify again?
Yes, ma'am.
Yes, they will still solidify. So it is still diffusion in solid. And the reason why we applied high temperature is because we want them to press together. Is that taken?
Yes, ma'am.
So it is still what? It is still solid and it is still diffusion in solid. Can we
Yes, ma'am.
move on?
Yes, ma'am.